Loudspeakers contain at least two magnet and cone assemblies known as drivers. They're typically housed in a box called the speaker enclosure. To build the internal magnetic structure, the factory begins by cutting two plates of iron, each about 13 millimeters thick. They go one at a time onto a lathe. First, the machining tool smooths and evens out the surfaces, getting rid of the marks the saw made. Then it cuts out a small hole in the center of one plate and a larger hole in the center of the other. Next, they cut a smaller and thicker round piece of iron called the core. A reamer bores a large hole through it. They apply super high-strength epoxy glue to the core and to the back plate, the plate with the smaller hole. They glue and screw the pieces together because the bond has to be strong enough to withstand intense magnetic pull. They glue a foam filter in the hole to ensure the vibrating cone doesn't draw in dust and cause internal damage. Now they spread glue on the narrow end of what's called the metal basket, a die-cast aluminum frame that will hold the magnetic structure and cone. They screw the front plate, the plate with the bigger hole, onto the glued surface. Then they glue the underside of the front plate and one side of a ferrite, a ceramic ring made from iron powder. After adhering the ferrite to the front plate, they apply glue to the other side of the ferrite, then flip the basket over to attach the back plate. The core fits through the large hole in the front plate. They insert shims to center it while the glue dries. After screwing terminals to the basket, they put the entire structure they've just assembled into a magnetizing machine. With 600 volts of direct current, the machine creates positive and negative poles, transforming the magnetic structure into a permanent magnet, meaning it has a constant magnetic field around it. Now they wind the voice coil, the electromagnet that will interact with a permanent magnet. An electromagnet is an object that generates a magnetic field only when there's a current running through it. They wind enamel-insulated copper wire, gluing it to a rigid plastic sheet. The positive pole of this voice coil will be attracted to the negative pole of the permanent magnet. The negative poles will repel each other. The key is that the voice coil's poles are constantly reversing position because the electrical current running to the speaker is an alternating current, meaning it switches between a positive and negative charge several times per second. This makes the magnets attract and repel each other continuously, causing the voice coil to move back and forth rapidly. This vibrates the cone, which creates sound waves. After slipping the voice coil between the front plate and the core, they glue on the bottom suspension, flexible fabric rings that move with the voice coil and prevent it from rubbing on the magnetic structure. Next, they glue the cone. It's usually made of cardboard, plastic, or metal. Then they solder the electrical connections. The current coming from the amplifier travels by wire to the two terminals. The terminal wires connect to the voice coil wires. After making sure the cone moves freely without rubbing, they glue on a rigid cardboard cap to keep out dust. The last step is to take the speaker for an audio test drive. They connect it to a machine that transmits different frequencies. They make sure the movement of the voice coil and cone isn't obstructed in any way. Then a computer device analyzes the sound wave the driver sends out. Two-way speaker systems have two drivers in each enclosure, a woofer and a tweeter. A woofer has a large cone that vibrates more slowly for low frequencies. A tweeter has a small cone that vibrates quickly for high frequencies. Three-way systems have a third driver with a medium-sized cone for the mid-ranges.